Thermodynamics in Biosystem Module 2, Basic Concept of Thermodynamics, Segment 3, Processes and Cycles. With me, Yusuf from School of Life Sciences and Technology, Institut Teknologi Bandung. Previously, we have discussed about system and its properties, as well as state and equilibrium. In this segment, we will discuss about processes and cycles. Any change that a system undergoes from one equilibrium state to another is called a process, and the series of states through which a system passes during a process is called the path of the process as shown in the figure. To describe a process completely, one should specify the initial and final state of the process, as well as the path it follows and the interactions with the surroundings. When a process proceeds in such a manner that the system remains infinitesimally close to an equilibrium state at all times, it is called a quasi-static or quasi-equilibrium process. A quasi-equilibrium process can be viewed as a sufficiently slow process as shown in the figure, that allows the system to adjust itself internally so that properties in one part of the system do not change any faster than those at other parts. But many actual processes closely approximate it, and they can be modeled as quasi-equilibrium with negligible area. Engineers are interested in quasi-equilibrium process for two reasons. First, they are easy to analyze. Second, work-producing devices deliver the most work when they operate on quasi-equilibrium processes. Therefore, quasi-equilibrium processes serve as standards to which actual processes can be compared. Process diagrams plotted by employing thermodynamic properties as coordinates are very useful in visualizing the process. Some common properties that are used as coordinates are temperature, pressure, and volume. The bottom figure shows a PV diagram of a compression process of a gas. Note that the process path indicates a series of equilibrium states through which the system passes during a process and has significance for quasi-equilibrium processes only. For non-quasi-equilibrium processes, we cannot characterize the entire system by a single state, and thus we cannot speak of a process path for a system as a whole. A non-quasi-equilibrium process is denoted by a dashed line between the initial and final states instead of a solid line. The prefix iso is often used to designate a process for which a particular property remains constant. An isothermal process, for example, is a process during which the temperature remains constant. An isobaric process is a process during which the pressure remains constant. An isochoric process is a process during which the specific volume remains constant. A system is said to have undergone a cycle if it returns to its initial state at the end of the process. That is, for a cycle, the initial and final states are identical. Steady flow process. The terms steady and uniform are used often in engineering, and thus it is important to have a clear understanding of their meanings. The term steady implies no change with time. The opposite of steady is unsteady or transient. The term uniform implies no change with location of a specified region. A large number of engineering devices operate for long periods of time under the same conditions, and they are classified as steady flow devices. Processes involved in such devices can be represented reasonably well by a somewhat idealized process, called the steady flow process, which can be defined as a process during which a fluid flows through a controlled volume steadily as shown in the figure. That is, the fluid properties can change from one point to point within the controlled volume, but at any fixed point they remain the same during the entire process. Therefore, the volume V, the mass amp, and the total energy content E of the controlled volume remain constant during a steady flow process. Steady flow conditions can be closely approximated by devices that are intended for continuous operation, such as pumps, boilers, condensers, and heat exchangers, or power plants or refrigeration systems. Some cyclic devices, such as reciprocating engines or compressors, do not satisfy any of the conditions stated previously, since the flow at the inlets and the exits will be pulsating and not steady. However, the fluid properties vary with time in a periodic manner, and the fluid through these devices can still be analyzed as a steady flow process by using time average values for the properties. In the next segments, we will discuss about temperature. Until then, I am Yusuf from Institute Technology.